Hey guys, it's all around Danny. In this video, showing you guys how to do an acid-base titration problem. So how your teacher might give it to you on a test or a quiz is that they're going to give it to you as a word problem. But right here, I'm just going to write the important pieces of information. So what we have here is hydrochloric acid that neutralizes with magnesium hydroxide. Now what they're going to ask you is that they want to know what's the concentration of magnesium hydroxide in this case. We can apply it to the acid as well. Now what concentration means is simply the molarity. And molarity, I'm going to write it off on the side, is moles over liters. Don't confuse big M with little m. Little m is molality, and big M is molarity. So now they give us, for hydrochloric acid, they give us 55, let's use easy numbers, 0.25 milliliters. Yes. And they tell us that it's 0.0521 molarity. Now, for magnesium hydroxide, they tell us that all they tell us is that it has a volume of 215 milliliters. And they want us to find, once again, concentration. So what we're going to do, the first thing we have to do is create a balanced equation. So we know that an acid plus a base, in this case our acid is HCl, plus our base, which is magnesium hydroxide, equals H2O plus a salt. Now a salt is simply a metal plus a nonmetal. So we would have to write this out. It would be MgCl2. And now we would simply have to balance it out. So we have two Cl's here, but only one, so we would add a 2 here. And now since we have 4 H's and 2 O's, we would add another 2 here. And that's our balanced equation. So now once we do this, we can start working to find the concentration of magnesium hydroxide. So what we start with, we always start with the solution that they give us the most amount of information for, obviously. So we start with the milliliters of hydrochloric acid. So we write 55.25 milliliters. And then we use the Menser analysis to turn this into liters, and then from there to moles, and then there to get our answer. So we do 1 liter over 1,000 milliliters times, and now what we can do to use this piece of information, we have to turn this into moles. And now we simply turn into moles by simply using the number that they give us, because molarity is moles over liters. So we can assume that the liters equals 1, right? So now we would write 0.0521 moles over 1 liter. And now this is where our balanced equation comes into play. We would use the moles that they gave us for our solutions, right? If they have any. If there's nothing in front of it, the moles are represented by this, by the number in the front, right? Now, if there's nothing there, that simply means it's a 1. You simply omit the 1, you don't write it. You assume that it's there. And so we simply start by writing what we're calculating for on the bottom. So there's 2 moles of HCl, right? Right here, as you can see right here. And we're trying to find the moles for NaOH. So we would write 1 mole at the top. And when we calculate this out, we would get, I'm writing the answer up here. In fact, I'm going to give myself more room, so I'm going to erase this. Alright, so we would get, give me a second while I put this into my calculator. Okay, so we would get a very large decimal. I'm going to write it right here. We would get 0.001439263. And now normally you would round the amount of significant figures, but I don't like rounding, and in fact my teacher told me to not round until the last step to get the most accurate answer. So I simply don't. So we're not going to round right now. And this is our moles, right? So now we're trying to find concentration, which is moles, which is molarity, which is moles over liters. So now we can finally use what they gave us for magnesium hydroxide. But the only problem is that molarity is with liters, not with milliliters. So we turn this into 0.215 liters, and now we can calculate our answer, which would be, it would be a really long decimal. I need to free up more space. Give me a second. You guys should have written down the balance equation. Okay. It would be a real large adjustment which would go as following: 0.006694244 m, and then we would simply simplify it. The amount of significant figures, which was 3, the lowest number of significant figures in whatever is given, is what we calculate our answer to. So we do 6.69 times 10 to the negative 3 m. And that would be our answer for the concentration of magnesium hydroxide. Thank you guys for watching. I'll see you guys in the next video.